Hello everyone. In this video, we are going to look into differentiation of power functions. So when we have x raised to certain power, how we would be differentiating. That is what we are going to look into. We have a formula for it, and the formula proof has been given separately in the videos. You can have a check pertaining to it. Right now, I'm using that formula how to do the problems, only that would be discussed. So we have d by dx of when I have something x which is getting raised to some power, then in that case, when I differentiate, I would be getting n into x raised to the power n minus 1. So this is the formula which I would be using to do the problems. So let's have a check pertaining to it. Differentiate with respect to x. Differentiate with respect to x. So let's have a look at our first problem. We have x raised to the power 5. So how to do this problem is considering whatever has been given as y, because this is a function, y is equal to, I'm considering. Then after this, what we would be doing, differentiating both the sides, differentiating both sides with respect to x. WRT is with respect to x. So in that case, I would be getting it as dy by dx is equal to. Now, if you are able to observe, it is x raised to the power 5. So, it is of this particular format. In that case, what I would be getting 5, where n is equal to 5 here. So, 5 into x raised to the power of 5 minus 1 instead of n minus 1. So, 5 into x raised to the power 4. Now, the second question. We have x raised to the power 9. So now what we would be doing here, okay, instead of considering it as y is equal to, you can also consider it as f of x is equal to x raised to the power 9. So now when I'm differentiating both the sides with respect to x, differentiating both sides with respect to x, in that case, what would happen? F of x will become f dash of x, which is nothing but dy by dx. And here, as per my formula, x raised to the power n. So here n is equal to 9. So n into, that is 9 into x raised to the power 9 minus 1, which is equal to 9 into x raised to the power 8 is my f dash of x. Hope you understood. Now let's do one more. We have x raised to the power of minus 4. So here n is equal to minus 4. Okay. So now when I differentiate, so how I would be considering, let y is equal to x raised to the power of minus 4. So we know what is our n now. When I differentiate both the sides with respect to x, in that case I would be getting dy by dx is equal to minus 4 into x raised to the power of minus 4 minus 1, which is equal to minus 4 into x raised to the power of minus 5. So I can write it as minus 4 divided by x raised to the power of 5. So because, see, the power which I have is the numerator with the negative power when that particular term will comes to the denominator, it becomes of positive power. So it is like x to the power minus 1 when we have it is equal to 1 by x. So that means in general, if I have to write, I would be writing it as x raised to the power minus n means it is 1 by x to the power n. So this is gonna be my general formula for this. Now let's go ahead with the next one. We have x to the power, not x to the power, let me go with 1 by x. So now here, we would be considering let y is equal to 1 by x, which is nothing but x to the power minus 1. So in that case, my dy by dx is equal to, what is my n? N is minus 1. So minus 1 x raised to the power of minus n minus 1. So n minus 1, right? So n is minus 1. So minus 1. So I would be getting minus 1 x to the power of minus 2. So I can write it as minus 1 divided by x square. This is gonna be my dy by dx. Okay. Let me do one more problem. E, it is 8. Only 8 has been given. Now we would be considering y is equal to, let y is equal to 8. So here I have only a constant, right? So now a constant is there, nothing is there. So in that case, here we have 1. What is 1? 1 is nothing but x to the power 0 is equal to 1. So whenever you find 1 or a constant number, just beside that, write it as x to the power 0. So that means y is equal to 8 into x to the power 0. So in that case, whenever I differentiated both the sides with respect to x, I get 8 into 0 into x to the power 0 minus 1. So that means any number multiplied by 0 is 0. So when you are differentiating, whenever you have a constant term alone without a x, in that case, the differentiation answer is going to be 0. So we can say in general, dy dx of k, whenever has been given, it is equal to 0, where k is a constant. Hope you guys understood with this. One last problem we are going to do, and with that we will wind up with these type of problems. So now we have cube root of x squared. So this is going to be my y. So let me consider, let y is equal to x squared whole to the power 1 by 3. The cube root I can write it in this way, which is x to the power 2 by 3 is equal to y. So when I differentiated both the sides with respect to x, I would be getting dy by dx is equal to n is 2 by 3, 2 by 3 into x into 2 by 3 minus 1. N minus 1 is the formula based on that. So here I would be having 2 by 3 into x to the power 2 minus 3 is going to be minus 1 by 3. So see here, when I take LCM here, I would be getting 3. So 2 minus 3 by 3. So it becomes 2 minus 3 is minus 1. So that's how you get minus 1 by 3. So you would be having 2 by 3 into cubed root of x. So that's your dy by dx. Or you can also write it as, if you are finding it like 3 and that one together. So in that case, Q3 and cube root together, you find it like a mess here. You can write it in this way as well. Dy by dx is equal to 2 by 3 into x to the power 1 by 3. Hope you understood this problems. So with these 5 problems, you would have got an idea about how to use this particular formula. Now, based on this formula, only few more problems we are going to do, but I would be introducing scalar multiple rule and addition and subtraction rule under differentiation. So let me just introduce two rules for you. Whenever I'm differentiating a function which is as a multiple of a constant and then f of x. For example, 4 times x square. So in that case, 4 I can take it out and then x square alone I can differentiate. That is what it means. So here I would be taking k out and then I would be differentiating d by dx of f of x. So in that case, I would be getting k times of f dash of x. That is what it means. So this is something very important. This is called as scalar multiple rule. Scalar multiple rule. This one is a quite important one. We would be using it every time. So no need to mention that it is a rule or something like that. Whenever you find a constant and a function, take a constant out and differentiate the function alone. Now the next one is addition or subtraction rule. Addition or subtraction rule. So here we have d by dx of two functions are getting added up or subtracted. That is what it means. F of x plus minus g of x. And if you want, you can add one more like h of x. Like this, if we have as many terms in general, we can have. Whenever we are having something like this, what happens is this d by dx is there. It operates on each and every term separately. That is what it means. So d by dx of g of x and then plus or minus d by dx of h of x. How many ever terms you have, it operates, the d by dx works with all the terms separately. So here I would be getting f dash of x plus or minus g dash of x plus or minus h dash of x. So these are the two things which we are going to use in our problems, especially in differentiation of power rule, power functions. So let's have a check with the problems based on that. So here, let's go with this particular problem, which is very simple. They are asking us to differentiate with respect to x. So differentiate with respect to x. That is what the problem is all about. So now what has been given is, let's continue the serial number, I think X, then we will go with G. G here, the question goes something like this. X cube into x square. Hmm. Okay. This is not coming under any of the rule which I told you just now, addition or subtraction rule or scalar multiple rule. It's like a normal thing here. We have y is equal to x cube into x square. The base is same, then the powers we need to add it up. So we would be having x raised to the power 5. Then when I differentiate both the sides with respect to x, then I would be getting 5x to the power 5 minus 1, which is going to be 4. So that's it. Got like this one has been done. So let's go with a different where. Okay. Now have a look at this particular problem. We have y is equal to 5x square minus x plus 1, something like this. So in this case, when I differentiate both the sides with respect to x, both sides with respect to x, in that case, I would be having dy by dx towards my LHS. And then when I differentiate here, I have d by dx of, that is what I would be having. I'm just making use of those rules and I wanted to show you very clearly how those rules work. So constant first comes out. So we would be having d by dx of x squared and then minus d by dx of x and then plus d by dx of 1. Now 5 into 2x when I differentiate x square. And then here when I differentiate x, it becomes 1. So minus 1. And the 1 is a constant. When I differentiate, I get 0. So the final answer is going to be 10x minus 1. That's my dy by dx. Hope you understood how to do this particular type of problem. Now one more problem we will do based on this. And then we will wind up with this type of problems. Now we have, okay, I. So let's start with the problem number I. So we have y is equal to 4x squared plus 3x minus 2 divided by root x. Okay, the problem is quite simple. It might be looking like a big thing, but it's very easy to solve. What we are going to do is we are going to split it up and write it. 4x squared by root x, because there's only one person in the denominator and three terms in the numerator. To all the three terms, the root x will be there. So plus 3x divided by root x minus 2 divided by root x. Now here we have 4x squared, right? Minus 1 by 2. What are we doing? See, when we have base same, a to the power m divided by a to the power n, here a is a base and m is a exponent, and here n is also a exponent, that is power, and this 2 here, a is a base. When base is same and the powers are of different, and when there is a division happening, where it is in the form of fractions or a rational number, in that case it is a raised to the power of m minus n. So that's the rule. And the same way when it is a product, then in that case I would be adding up my powers, m plus n. The same thing I'm doing it here. Plus 3x raised to the power 1 minus half. Minus 2, we have x. If nothing is there, it is x to the power 0. Okay. So let me just write it as x raised to the power minus half, because I told you how this one works. That also I will just write it here. 1 by x to the power n is nothing but x raised to the power of minus n. So based on that. Now we have 4 into x to the power 4 minus 1 is going to be 3 by 2 plus 3 into x to the power half minus 2 into x to the power minus half is my y. When we differentiate both the sides with respect to x, we get dy by dx is equal to 4 into 3 by 2 into x to the power 3 by 2 minus 1 plus 3 into 1 by 2 into x to the power 1 by 2 minus 1 minus 2 into minus 1 by 2. Whatever your n is there, it will come as it is. X to the power minus 1 by 2 minus 1. Let me just erase it a little. So minus 1 by 2 minus 1. So done with my differentiation. Now just we will go with simplification. We would be having 6 x to the power 3 minus 2 is gonna be 1. So it's gonna be 1 by 2. Then here plus 3 by 2, x raised to the power minus half, and then here minus minus becomes plus, and then even 2 gets cancelled. So plus x to the power minus 1 minus 2 by 2. So it's going to be minus 3 by 2. That's it. It's been done. This is my dy by dx. Hope you guys understood the problems based on differentiation of power functions. So this formula is very much important, and these two rules are also plays a fair role in our problems. So with this, I will wind up with this video. In the next video, we will be doing differentiation using trigonometric and other other things, logarithm, everything. Okay. Thank you guys.